The resultant force on an object is like the overall force acting on it. You'll often come across resultant forces in a diagram. So in this example, the resultant force would be 5 newtons this way. In this example, the resultant force would be 2 newtons downwards. So we can find resultant forces with a simple bit of addition and subtraction. If they go the same direction, you add them. If they go in opposite directions, you subtract them. Let's test your understanding. What would the resultant force be in this scenario? That's right, it would be 8 newtons upwards. And that's because going upwards we'd have 20 newtons overall, going downwards only 12. 20 minus 12 is 8, and because that side was the biggest, it goes upwards. Now it's possible, especially if you're doing a higher, that you'll have to resolve forces that are going diagonally. This involves a bit of trigonometry. A real common one they go for is when, say, a boat is being towed by a rope, something like this. Now know that resultant forces can come from forces in different directions. Now we can resolve a diagonal resultant force into 2 components, a horizontal and a vertical component. Notice that in doing so, we must have made a right angle triangle. Therefore, mathematicians, we could use Pythagoras and trigonometry. Since this involves an angle, we'd have to use trigonometry. That's the SOHCAHTOA stuff. Let's say that diagonal force is 25 newtons. If you want the vertical component in this case, that would be the opposite. The other side that's useful is the hypotenuse. So we have O and H. That means to find it, we need to use sine. Writing out SOHCAHTOA like this helps you remember to find the opposite, you need to do sine of the angle times by the hypotenuse. What if we wanted the horizontal component? Well, in this case, that would be the adjacent side. So the useful sides would be our hypotenuse and adjacent. That tells us we need to use cos. Again, if you want the adjacent, writing it like that tells you need to do cos of the angle times by the hypotenuse. Now do remember to check yourself. Remember that diagonal, which is opposite the right angle in your triangle, must always be the longest side. So if either your vertical or horizontal are greater than that, you must have made a mistake. Lastly, you could be given a vertical and horizontal component and asked to find the size of the resultant. It's vital that you remember with this to put your forces tip to tail. So the tip of one arrowhead goes to the tail of the next. Then your resultant is simply from the beginning to the end of those vectors you've put together. Notice again that we've made a right angled triangle, so if you had to, you could do some Pythagoras theorem this time because we've only got lengths involved to find that hypotenuse. And just remember to double check your hypotenuse should be the longest, so if it's not, you've done something wrong. Was that useful? I hope so. Please leave a like if so, and let me know in the comments if there's any other video requests you might have.